Okay, so now we have question number 3 from C2 June 2014, the legacy paper. Question about binomial expansion. We are asked to find the first three terms in ascending powers of x of the binomial expansion 2 minus 3x to the power of 6. As I mentioned before, there are many methods that we can use to solve such an equation, such a question. However, I prefer to use the method which will have to be used in further studies in C3 and C4, okay, which is this method here, because the NCR method that many people use, which, you know, those methods will only be, you know, viable when you have a positive integer power. Okay, when you have negative or fractional powers, it doesn't work. So you won't be able to use that in questions to do with binomial expansion in C4. So it's much better for you to get used to using this particular expansion, which is pretty simple to remember. In fact, they give it to you in the formula sheet anyway. So it has to be in the form 1 plus x to the power of n, x meaning whatever term is in that place here. And it always will expand in this form, 1 plus n times x, the power times whatever's there, plus n times n minus 1 over 2 factorial, means 2 times 1, times whatever number's here, squared, plus, and so on it continues, n times n minus 1 times n minus 2 over 3 factorial times whatever numbers in that place here, cubed. Okay, so that's the form of the expansion. So we can apply to this, but the first thing we've got to realize is there must be a 1 here, not a 2. So we've got to get rid of that 2. So you've got to do the following. So what I'm going to do is I'm going to take out 2 as, in inverted commas, a factor. So I'm left with the 1 here. Okay, now I'm thinking to myself, what do I have to multiply by 2, all right, to give me 3? Okay, to give me 3. 2 times, well, 3 over 2, isn't it? 2 times 3 over 2 will give me 3. Okay, 2 times a half of 3 will give me 3. So I've got to write 3 over 2x, negative 3 over 2x in this place, and all of this is raised to the power of 6, which you can write separately. This is like 2 to the power of 6 times 1 minus 3 over 2x to the power of 6. Now 2 to the power of 6 is 64. Confirm that. 2 to the power of 6 is 64. 2 to the power of 6 is equal to 64. That's right. So we know this is going to give you 64 times 1 minus 3 over 2 x to the power of 6, which will be 64 times. I always like to write the 64 out there because sometimes you forget to multiply by it if you just leave it separate. So you got 1 plus nx, so 1 plus n, which is the power, and x is whatever term is here, including the sign. You've got minus 3, I'll write it as 3x over 2, okay, that's to the power of 1, basically. Plus, and it says find the first 3 terms, so I've only got 1 term to go, that's 1, 2, and then 3. So you've got n, which is 6, times n minus 1, which is 5, over 2 factorial, which is 2 times 1, which is 2, times, and you got minus 3x over 2, this time it's going to be squared. That's as far as we need to go. Okay? So you have 64 times, you've got 1, and you're going to have a minus. This is plus times minus is minus. The 2 and the 6 cancel to give you 3, so you got minus 9x. Okay, and here the 2 and the 6 cancel to give me 3, so you got 15, so you got plus, it's going to be positive, because this becomes a positive when you square it, so plus 15, okay, and then I'm going to square these, so you're going to have 9x squared over 4, 2 squared is 4. Okay, so we're almost there, so you got 64, let me try and be neater than that, so you have 64 times 1 minus 9x. Now you've got 15 times 9, okay, which is 15 less than 150, which is 135. Let's just make sure. 15 times 9 gives you 135. So you've got plus 135 x squared over 4. Okay, which then simply becomes 64, 6 times 1, 64 times 1, minus 9 times 64. So you have 64 times 9, which gives us 576. So 576x. And you're going to have plus, and you're going to have, well, 64 divided by 4 is 16. So it's 16 times 135. So 64 times 135 divided by 4, which gives us 2,160 x squared. 2,160 x squared. So there's the answer to part A. I'm going to do part B in the next video.